So this is the first paper that we're doing, June 2022, paper 3, variant 1. Let me know that you want me to do from this paper. Today is the last past paper class that we're having, and we're doing some past papers. We've already done all the papers from 2020 to 2025. Some complete papers, for some only the difficult questions. You've got the recordings available for the rest of them from 2020 onward as well. So from 2020 to 2025, you've got all the papers, their recordings, their notes, their solved notes. You can have a look at all of them. For some, we have completely solved them, and for others, we have only the difficult questions solved. Okay, so make sure that you make use of all of that now over the next 3-4 days in your final preparation. Tomorrow and the day after tomorrow, we will have the P3 revision workshop, right, in which we will be covering all the concepts that we have in paper 3 for all topics. We will speed run through everything, all concepts, and also any difficult and the different types of questions that you see on those topics and older past papers and recent past papers, especially the recent past papers. We'll have a look at all of that over the next 2 days now as well. Tomorrow and the day after tomorrow, we will start around 4:30 inshallah tomorrow, and similarly on Saturday as well, and we'll go through the whole syllabus. Okay, both the concepts and the different types of questions that you see on each of the topics that we have in the syllabus. Okay, so that's the plan for tomorrow and Saturday. And then on Sunday, we will just have a live Q&A session in which you can ask any last minute questions that you might have. That will be a general session in which you can come with any kind of questions that you might have. Okay. All right, so let's begin with this. June 22, paper 3, variant 1. Let's have a look at the difficult questions from this paper first of all. So from this paper, you're asking about question number so just checking something here. My other device is lagging a bit. Yes, in the recent papers, complex numbers questions, they are indeed quite complicated. So for complex numbers, you do need to make sure that the recent papers, you do all the complex numbers questions in them. They are quite difficult in the recent papers. Okay, so June 22, paper 3, variant 1. Let's have a look at some questions from this. Okay, question number 1, you guys are okay with that. Question number 2, this is just binomial expansion. This equation, this is cot 2x. All you have to do is, first of all, write it like this: 2 over tan of 2x plus 3 over tan of x equals 5. Apply the double angle identity for tan. The double angle identity for tan that we have looks like this: tan of 2a is 2 tan a divided by 1 minus tan square of a. We'll apply this identity here, simplify this. It will most likely become a quadratic equation. It will become a quadratic equation, and you just solve that quadratic equation. It's not that difficult. You can try. You can try this, and you should be able to do this. Let's move on. Not a lot of people have asked about this, so if you try, you should be able to figure this out. This is the differential equation question. You separate the variables. Once you separate the variables, you apply the ln rule on both sides. In this case, on the left side, you have 1 over y. On the right side, you have x over 1 plus x square. On both sides, you can integrate using the ln rule. That's also not that complicated. Okay. All right. Nobody's asked about this as well. This is the first question for which we have more votes. Let's start with this one. Question number 6 from this paper. Question number 6 from this paper. It says, using this substitution, x equals 3 tan theta show that I equals this. So we have to convert this integral to this form first of all. That's the first thing we have to do. Okay. Now, how can we do that? Let's try this. So the substitution that we're given is x equals 3 tan theta, right? That's the substitution that's given. The first thing we do is we find the derivative of this. It becomes dx over d theta. What's the derivative of tan? Derivative of tan is secant. So it becomes 3 secant square theta. Now, in that integral, we have to replace dx as well. Let me just write that integral here. That is 27 over 9 plus x squared whole squared. This is what we want to integrate. The limits for x are from 0 to 3. So we make dx the subject from here as well. So we can replace that as well. That would become 3 secant square theta d theta. Right? This is what we end up getting from this. Now, we input these two things in that expression. In place of x, we input 3 tan theta. In place of dx, we input this. All right, let's do that. Let's input these two things here. Instead of x, you input 3 tan theta. So that would become 9 plus 3 secant square theta. That's 9 plus x squared, right? Okay, I'm sorry. What am I writing there? 9 plus 3 tan theta. 9 plus 3 tan theta whole squared. That's what you have here in place of x. And then there's a whole square here as well. So we put a whole squared. And then in place of dx, what we do is we write 3 secant squared theta d theta. So what I've done is I have replaced x squared, or just x, with 3 tan theta, and dx with 3 secant squared theta d theta. Right? So that substitution is done. Now everything has been converted to theta. There's nothing that is left in terms of x. Now let's change the limits as well. You have to show that working as well. Let's write down lower limit here and the upper limit here. The value for x for the lower limit is 0. The upper limit is x equals 3. What are the corresponding values of theta going to be? X is equal to 3 tan theta, right? So we can say 0 equals 3 tan theta. 3 will go to the other side, get divided, and just give us 0. And tan theta equals 0. You find tan inverse of that. That will also turn out to be 0. What about this? 3 equals 3 tan theta. That will become 1 equals tan theta. And the value of theta that you get from this when you do tan inverse 1, that is going to be pi over 4. So you show this process in which you change the limits. Showing this working is important. Okay, you have to make sure that you show this working. All right. Now, let's change those limits as well. Those limits are going to become 0 to pi over 4. Now we have to simplify this and convert it to this form. Now, after this point, it's just using trigonometric identities, right? It's about trigonometry. After this point, you've done the substitution part. Now we just have to use trigonometric identities to convert to that form. Okay. Now, how can we do that? We want cos square theta eventually. Now, right now in the denominator, we have 3 tan square theta. Let's actually first simplify this and see what that gives us. In the denominator, we get 27 divided by 9 plus 9 tan square theta. 3 squared is 9, and then tan theta whole squared, that's tan squared. And we have whole squared outside. Integration of this times 3. I can simplify the numerator. 27 into 3, that's 81 into secant square theta d theta. Okay, so now how do we simplify this? Now, one idea could be that you expand this, but that's going to make things complicated. We want to simplify this. Do we have any relation between tan and secant, right? Because we want to do some cancellation. The eventual result that we want, that does not have any fraction in it, right? It does not have any fraction in it. So we want to eliminate the fraction. That means we have to do some sort of cancellation somehow. Now, what cancellation? We could use the identity. We know that secant square and tan square, they're connected with each other. You have to remember this. If you don't remember this, you will not get this idea in the exam. Even if you have the formula sheet, if you don't remember that tan square and secant square, they are connected with each other, it will become difficult to figure out in the exam. You don't have so much time in the exam to, just look at the formula sheet and find that identity that connects these two. The minimum you have to remember is that there is one identity that connects these two. That's what you need to remember. And then the exact identity, you can go to the formula sheet and find that, but at least you should know that they're connected. So the identity that we have between them is that 1 plus tan square theta is secant square theta. So we could say tan square theta, therefore, or we could actually simplify this. I could take 9 common from the denominator. So I have 81 secant square theta. And in the denominator, I have 9 common outside into 1 plus tan square theta. And then whole square like this. And now you see in the denominator, what do we have? 1 plus tan square theta. What do we know about that? 1 plus tan square theta is secant square theta. So I can replace this with secant square theta. Let's do that. It becomes 81 secant square theta divided by 9 squared. What does that become? That becomes 81. 1 plus tan square, I can replace that with secant square. So this can be written as secant square theta. Or let me actually write it like this first. This is 9 secant square theta and whole square. The square is still there. Let's simplify this further. 81 into secant square theta. Now let's expand that square in the denominator, and that will give us 81 secant raised to power 4 theta. So I've replaced 1 plus tan square with secant square here, and then there's another square outside. So that becomes secant raised to power 4 theta. 81 and 81, they get cancelled. Secant square gets cancelled with 2 power of secant, and we're left with secant square after that in the denominator. So we have 1 over secant square theta. What do we want to prove at the end? Integration of cos square theta. That's what you wanted to prove. Secant is reciprocal of cos, so that will just go to the numerator now and become cos. So we get cos square theta d theta, and the limits are from 0 to pi over 4. We wanted to prove that integral that we started from, which was I, that can be written in this form. And that's what we have done here. We've written that in the required form. And that's what we had to do in this part. That's our final result. Okay. Does that make sense to everyone? Any problems with this? Any questions, anyone? No problems? Okay, good. Now, the formula sheet that you get for paper 3, so some people are asking about it. Let me just show that to you. The formula sheet that you get for trigonometry, in fact, for the formula sheet, right? These are all the identities that are the ones that you see in black. This you should remember. If tan is sine over cos, then cot is cos over sine. But the other ones are all given here. You can see them here. Sometimes you have to make these half angle identities from this as well, using the double angle identities. You can look at the notes for that. You have access to these notes in the group description and WhatsApp group description. You can have a look at that. Okay, so that's what you get in the first part. Now it says, hence find the exact value for I. How do you do that? I equals integration of cos square theta, and the limits are from 0 to pi over 4. That's what you want to integrate. 0 to pi over 4, cos square theta, these are the limits. How do we integrate cos square? How are even powers of cos integrated? For even powers of sine and cos, what we do is we use trigonometric identities. Now, what's the identity? What's the identity that we're going to use here? The double angle identity for cos. Cos 2a is 2 cos square a minus 1. We can use that identity. Make cos square A the subject, and that will give you cos square A equal to 1 plus cos 2A divided by 2. Now we've got cos square theta here. So we can say cos square theta would therefore become 1 plus cos 2 theta divided by 2. So we can replace cos square theta with that. And that makes it very straightforward. Then you have 1 plus cos 2 theta whole divided by 2. We can write 2 outside. So it becomes 1 over 2 times integration of 1 plus cos 2 theta. What's the integration of 1? That is theta. Integration of cos 2 theta, that is sine 2 theta, divided by the derivative of 2 theta, which is 2. And that's the integration that we get. You can input limits now from 0 to pi over 4 and see what that gives you. You have to show this working. You cannot just put this on a calculator directly and write down the final answer. That's not allowed, especially when they say exact value. You have to make sure that you show all working. So now what you do would what you would do would be you input pi over 4 in this one, and that gives you pi over 4 plus sine of 2 pi over 4 divided by 2. Subtract from this the case when you input theta equal to 0, and that gives you 0 plus sine of 0 over 2. Now we could simplify this and see what that gives us. We've got 1 over 2 outside as it is. Inside we have pi over 4 plus sine of pi over 2. Sine pi over 2, you can put that in a calculator. That's actually 1. So that's 1 over 2. This all is 0. This is 0. The second term is also 0 because sine 0 is 0. And this is what we're left with. We could simplify this further. The final result turns out to be pi over 8 plus 1 over 2 times 1 over 2. That is 1 over 4. And that's our final answer. That's what we were looking for. You can confirm this now, but using a calculator as well. Just put this on a calculator and see what that gives you. Make sure your calculator is in radian mode. First of all, you could put this integral in your calculator. Integration is cos theta whole square. Now on your calculator, you have to do this in terms of x. You input cos of x, and then you have whole square of that. That's what you have to integrate. Limits are from 0 to pi over 4. Right? These are the limits. Now that's giving me 0.6427. Now you could check this answer in decimals as well and see what this gives you. Pi divided by 8 plus 1 over 4. That's also the same thing, 0.6427. That means your answer is correct. Just leave it as it is and then move on to the next question. Any issues with this? Any problems, anyone? Make sense? Oh, I forgot to connect the LAN. Let me connect the LAN. Is my voice lagging for anyone here? Is my voice lagging for anyone here? No? Okay, all right. Started the recording as well. Start that. Okay, no problems. Okay, this is ongoing on here. We'll have a 1 minute break for that, and then we resume the next one. This was question number 6. Okay, let's look at this one now. This is the next question that you're asking about from this paper, question number 7. Let's try this. You have this complex number where a is a positive integer. We first have to express u in terms of a in the form x plus y iota, where x and y are real. Okay, now that's the standard part. You just have to multiply and divide by the conjugate of the denominator, and then simplify that. So u equals under root 2 minus a into under root 2 iota divided by 1 plus 2 iota. That's the complex number that we've got. How do we simplify this? We multiply and divide by the conjugate of the denominator, and that becomes 1 minus 2 iota. You multiply and divide by that. Simplify this now. In the numerator, when you multiply these two expressions, what do you get? Under root 2 into 1, that's under root 2. Under root 2 into minus 2 iota, that's minus 2 under root 2 iota, minus a under root 2 iota, plus 2a or 2 under root 2a iota squared. This is what you have in the numerator. In the denominator, this is a plus b into a minus b, right? What does that become? That becomes 1 squared minus 2 iota whole squared. Now we can simplify this. In the numerator, we're getting under root 2. That's one real number, and this is also real. We can write that together with this, plus 2 under root 2 a into minus 1. These are two imaginary terms. We can write them together, minus 2 under root 2 iota minus a under root 2 iota. In the denominator, we have 1 minus 4 iota squared. That becomes minus 4 into minus 1. And now the denominator is 5, right? We have to write our answer in the form x plus y iota, real part separate, imaginary part separate. So how would you write that? What's the real part? This whole thing divided by 5. So the real part, we can write that separately like this. Under root 2 plus 2 under root 2. There's a minus there, sorry. Under root 2 minus 2 under root 2a divided by 5. That's the real part. Plus the imaginary part. You can take minus common if you want, or just leave it as it is. That's your choice. It doesn't matter. Minus 2 under root 2 iota minus a under root 2 iota whole divided by 5. You could take iota common outside. So we have it in exactly that form. We could say this is minus 2 under root 2 minus a under root 2. Minus 2 under root 2 minus a under root 2 whole times iota. This is what the number turns out to be in x plus y iota form. Make sense to everyone? Any problems with this? So you just have to multiply and divide by the conjugate of the denominator, and that's it. Okay? All right, let's move on. Let's move on to the next.
Yes? Sir, क्वेश्चन में आयोटा रूट के अंदर नहीं था?
कहाँ पे रूट के अंदर था?
सर ये जो आयोटा लिखा हुआ है रूट 2 के साथ, वो रूट के अंदर नहीं है?
नहीं, रूट के अंदर क्यों होगा वो?
अच्छा, ठीक है सर.
It was always outside. It was outside. You can see the root is only up to 2 here, right? We have proved that u is equal to this. Under root 2 minus 2 under root 2. I think I'm a bit too small for you. So I'll just copy this here instead. Okay, so this is what we have shown in the first part, right? That u equals this. U equals this. Now, what's the value of 3 that we've got? What's the value of 3 that we've got? A that we've got. The value for a is 3. We can input that here. so that u becomes under root 2 minus 2 under root 2 into a. What would that be? 6. 6 under root 2 divided by 5 plus minus 2 under root 2 minus 3 under root 2 divided by 5 times iota. Let's simplify this. Under root 2 minus 6 under root 2. What does that become? Minus 5 under root 2 divided by 5. Right? These are the same terms, under root 2 and under root 2. So we can add and subtract them. 1 minus 6, that's minus 5. What do we get from that? Minus under root 2. And then from the other two terms, we're getting minus 5 under root 2 divided by 5 times iota, and that becomes minus under root 2 iota. This is what u turns out to be. Right? That's the value of u that we're getting. Now, what do we do now? We have to find the exact value of r and theta. Right? We have to express u in this form. How do we do that? Let's find the modulus of this and the argument of this. What's the modulus going to be? Square root of under root 2 whole squared plus under root 2 whole squared. That's how we can find the modulus and see what that turns out to be. What do we get from this? 2 plus 2, square root of that, that's 2, right? And then what about the argument? What about the argument? Let's see what that turns out to be. Find the basic angle first of all. Tan of alpha, that is equal to the imaginary part divided by the real part. So under root 2 over under root 2. Let's see what that gives us. That's 1. The basic angle will turn out to be pi over 4 from this. That's the basic angle. Now, which quadrant are we in? Real part is negative. Imaginary part is also negative. So that means on the left side and down here, both are negative. So the basic angle is going to be here. Okay, I'm sorry. I think I'm getting some internet issues. Can you guys see my screen again? I think it's connected again. Can someone please confirm if you can see my screen again? Yes, no? Okay, all right, thank you. Achha. So that's the first part. We had to find the modulus. We had to find the modulus and the argument. We had to find the modulus and the argument. Once we have found them, the modulus and the argument, all we have to do now is write it in that form, re raised to the power iota theta. So that will become 2e raised to the power minus 3 pi over 4 times iota. And that's your final answer. Make sense? Any issues with this? Any problems, anyone? No problems? No issues? Okay, let's move on. That was part B. Now it says, using an answer to part B, find the two square roots of u, giving an answer in the form r e raised to power iota theta, where r is greater than 0 and theta is between minus pi and pi. How do we do that? In r e raised to power iota theta form, how do we find square roots? We know that u is equal to 2e raised to power minus 3 pi over 4 times iota, right? That's what u is. How do you find square root? One square root would just be this. You just take power 1 over 2 on both sides. So you have 2e raised to power minus 3 pi over 4 iota whole raised to power 1 over 2. The first square root, what does that turn out to be? The first square root turns out to be 2 raised to power 1 over 2. That's square root of 2. Into e raised to power, this power 1 over 2 will get multiplied with this power minus 3 pi over 4. And that's going to give us minus 3 pi over 8 times iota. This is one square root. This is one square root. Okay. This is one square root in this form that we were looking for. What about the other square root now? How do you find that? Now, we should remember that property of square roots of a complex number, that they are pi radian rotation. No, yes. Square roots are not conjugates. Square roots are not conjugates. You need to remember the relation between square roots of complex numbers, and that is that they are pi radian rotation of each other about the origin. Let me show that to you. In r e raised to power iota theta form, the way to find square roots is using this property. Square roots are pi radian rotation of each other about origin. If you have one square root, the other is going to be right on the opposite side like this, right? If you know one, you can find the other by either adding pi to the argument or subtracting pi to the argument, right? There's a whole background to this. This was the takeaway that we had for this. For the second square root, if the first argument is positive, we will be subtracting pi. If the first argument is negative, we will be adding pi to get the other square root, right? So that will do a pi radian rotation. So all we have to do in this case is, we have one square root. The other is going to be a complex number that has the same modulus. Modulus will remain the same. That's under root 2. For the argument of the first complex number is, for the first square root is minus 3 pi over 8. For the other, for doing pi radian rotation, all we have to do is add pi to it, right? And that will give you the result. You can see what that is. That's 5 pi over 8. That's the argument of the other complex number, of the other square root. That's 5 pi over 8 iota. If the first argument was positive, for the second one, we would do minus pi. Okay. And that will do pi radian rotation. That's the result that we're getting. Okay. Any problem with this? Yes, Safir, you can use that. You can use that, yes. That's a general method that we have for any root, for cube root, fourth root, etc. But in our syllabus, we only have square roots. So this is sufficient, but you're right. In general, we could do something like that. Yes. When do we do that working for squaring on both sides? That is when you have that other form x plus y iota. When you have to find square roots in this form, then we assume the square root to be this. For example, if we're finding square roots of 8 plus 17 iota, let's suppose we say, let's assume x plus y iota is the square root. Then x plus y iota whole squared, that is equal to 8 plus 17 iota. And then we use this to find the values of x and y. Because in that case, if we do power 1 over 2 here on the other side, so square root is actually going to be this, right? X plus y iota, that will be 8 plus 17 iota power 1 over 2. But the problem in this form is that we cannot evaluate this power 1 over 2. We'll have to use binomial but that does not give us an exact answer. It's going to be an infinite sequence, right? And P3 binomial, you see what happens when you have a fractional power. It has infinitely many terms, so this cannot be expanded. So for this, we used to do it like this. We would square the other side, x plus y iota whole squared. We would square that, compare both sides, find the values of x and y. Okay. अगर 3 square root find करने होते हैं, how does that make sense? How would you have 3 square roots? Square roots are only 2, right? In real numbers as well, you only have 2 square roots. How do you find 3 square roots? That does not make sense. For any number, you only can have 2 square roots, not more than that, right? Okay. What about the next question now? I lost that chat here. Okay, so the next question from this paper that you're asking about, let me have a look at that. Okay. 8. Okay, which specific part of 8? Which specific part of 8? I'm assuming the first part is straightforward. So only the second part? Only the second part? Yes. Okay, all right. Let's do the second part of this first. Just the second part of this. The first part is not that difficult. It's just implicit differentiation. You'll find the derivative. Can somebody tell me the answer for the first part? You have to do implicit differentiation, right? Okay, I'll do one step for you, and then you just have to make dy over dx the subject. After that, it'll be 3x squared plus 3y squared into dy over dx. And then you have to use product rule here. That will become x into dy over dx plus y into 1 plus 0. Derivative of 8 is 0. On the other side, you've got 0. You'll make dy over dx the subject, and that will give you a result. You can see what dy over dx turns out to be from this. Does anyone have the answer for this so that we can move on to the second part quickly?
So minus 3x squared plus 2y.
Minus 3x squared plus 2y
divided by 3y squared plus 2x.
Plus 2x. Is this minus with the fraction or just with 3x squared?
It's a fraction.
Okay, so we could then put it like this, minus and then bracket, and then like this. If you write it this way, minus 3x squared, that would be wrong. You will lose a mark, because if you write minus here, that is basically implying that this minus is only with 3x squared. Okay, so if you have to write it with the fraction, either clearly write that here or use brackets, so that makes sure that this minus is multiplying with the whole thing. Okay, that's the answer that you get from the first part. Okay, now let's look at the second part. It says the tangent of the curve at the point where x is 0 and the tangent at the point where y is equal to 0, they intersect at the acute angle alpha. Find the exact value of tan of alpha. Okay, so we have two tangents and they're intersecting at some point, and they're saying this angle is alpha. We have to find this angle. Angle between two lines, does that remind you of something? P1 coordinate geometry, we study this there. How to find angle between two lines? The formula for that looks like this. Tan of theta, in this case the angle is alpha, we can say tan of alpha, that would equal m1 minus m2 divided by 1 plus m1 into m2, right? That's the formula that we've got for angle between any two lines. We want to find angle between these two tangents. So what we need is the gradients of these tangents. We want to find the gradients of these tangents. How can you find the gradients of these tangents? We have the derivative that we found in the first part. The derivative is dy over dx equal to minus into 3x squared plus 2y divided by 3y squared plus 2x. That's the derivative that we have, right? Using this derivative, we can find the gradients at these points. So for example, put x equal to 0 here, but the problem is we don't know what the value of y is at that point. So we have to find the corresponding y value for the first point and the corresponding x value for this point first of all. Let's do that. Let's find those points. We only know the x and y coordinates for now. So at one point, x is equal to 0. At the other point, y is equal to 0. What's the function? The function that we have is x cubed plus y cubed plus 2xy plus 8 is equal to 0. That's the equation of the curve that we have. If x is equal to 0, what's the corresponding value of y that we get from this? Let's figure that out. If x is 0, we get 0 plus y cubed plus 0 plus 8 equals 0. Y cube equals minus 8. Y equals minus 2. So this first point that we're talking about, that is 0 and minus 2. If y is equal to 0, we get x cubed plus 0 plus 0 plus 8 equals 0. And that also gives us x cubed equals minus 8. And the value of x turns out to be minus 2. So the other point is minus 2, 0. We are looking for the gradient of the curve at these 2 points. Whatever is the gradient of the curve at these points, the gradients of the tangents at these points would also be the same, right? Gradient of a tangent is the same as the gradient of the curve at that point. So that's what we can do. We can input these 2 points here and see what that gives us. Let's once input the point 0, minus 2, and then we can input the other point, which is minus 2, 0, and see what that gives us. Okay, so when we input x0 and y minus 2, let's see what we get from that. 0 plus 2 into minus 2 whole divided by 3 into minus 2 whole squared plus 0. Let's simplify this, and that will give you a value. Has somebody done this? What's the result that you get from this? Please let me know the result from that. What about the other gradient? Minus into 3 into minus 2 whole squared plus 0 divided by 0 plus 2 into minus 2. You get some values from this. In the first case, you have 4 divided by 12. I think that's 1/3, right?
Yes, sir.
And the other one, minus 12 divided by minus 4. Is that 3? Second is 3. Okay, thank you. So 1/3 and 3, these are the values of the gradients that we're getting. Now, these are gradients of the curve at these 2 points. Gradients of the tangents would also be the same, right? Whatever is the gradient of the curve at that point, the gradient of the tangent would also be the same. So we can say one of these is a gradient of one tangent, let's say gradient of tangent 1, and the other one is gradient of tangent 2. Now, what is it that we're looking for? They are saying they intersect at the acute angle alpha. Angle is supposed to be acute. If angle is acute, in which quadrant is an acute angle? The first quadrant. So that means the value of tan should be positive, right? Because in the first quadrant, tan is positive. We need a positive answer at the end. All we have to do is input values in that formula. Tan of alpha equals m1 minus m2 divided by 1 plus m1 m2. We just input values in that formula, but while inputting values, use m1 as the number that is bigger and m2 as the number that is smaller. Why? Because that will give you a positive value for tan. We want a positive value for tan, right? Because alpha is acute. That means it's in the first quadrant. In the first quadrant, all ratios are positive, sine, cos, tan, they're positive. So we want a positive answer at the end. In order to get a positive answer, we use m1 as the bigger number and m2 as the smaller number. So we could say this is 3 minus 1/3 divided by 1 plus 3 into 1/3. And that will give you the result. You can see what that is. In the numerator, you get 8/3. in the denominator, you have 1 plus 1, which is 2, and that simplifies to 4 over 3. So tan of alpha, that is equal to 4 over 3. That's what we were looking for. Okay. Any problems with this? Any questions, anyone? No problems? Show the working. I can show you the whole working. Okay, good. So that was question number 8 from this paper. Now the next question that you're asking about from this paper is 9, and that's it from this paper. But before we do this, we'll have a break now for Maghrib. Let's have around a 10-minute break for Maghrib, and then we come back after that to do question number 9, and then we'll move on to the next paper after that. Okay, around 10 minutes break, and then we come back after that.
Baba.
Okay, let's resume. So this is the next question that we're doing now. It says in the diagram OABCDEFG is a cuboid in which OA is 2 units, OC is 4 units, OG is 2 units. Okay, let's just mark those mark those distances. OA, this is 2 units. OC, where is that? OC is 4 units. Okay. And OG is 2 units. The point M is the midpoint of DF. Okay. This is one important piece of information. And the point N on AB, the point N on AB is such that AN is equal to 3NB. This point, okay. Find OM and MN in terms of I, J, and K. Now, how can we do that? First of all, let's write down the vectors that we know. We know that vector OA, that is 2 times I, right? It's in the I direction and its magnitude is 2. So we say that's 2I. Similarly, OC, what would this be? OC is 4 times J, and OG, that is 2 times K. OG is 2 times K. Okay? These are the 3 vectors that we're given. Now, how do you find OM? We have to start at O and reach the point M. M is the midpoint of D and F. I told you about the midpoint formula in the last class as well. If you have 2 points, for example, you have A and B, and you want to find the midpoint of them, you would say OM that would be OM is half of OA plus OB, right? We could use that directly. That will save some. D and F are the points for which M is the midpoint. Can we find the position vectors of D and F first of all? What is OD? OG, sorry, OD. Yeah. OD, what's that going to be? Start at O and reach the point D. How can we do that? We can go in this direction and then in this direction. If OG is 2K, AD is also the same. That's also the same vertical line, 2 units in the same direction. This is also 2K. So this is the same thing as AD as well. So OD vector, that would be 2I plus 2K, right? So we're going like this way, and then this. That's 2I plus 2K. That's the. Then what about the vector F? Or the, can we find that somehow? OF. We have to start at O and reach the point F somehow. We could say, let's go in this direction. That's 4J. And then let's go here. CF. That will be 2K, right? That's the same thing as OG as well. So that will be 2K. So OF vector, that is 4J plus 2K. Okay. And now M is the midpoint. M is the midpoint. We could use the direct formula for this. OM vector, that is equal to half of OD plus OF. Input values in this and see what that gives you. 1/2 into 2i plus 2k plus 4j plus 2k. See what that simplifies to. This gives me 1/2 times 1/2 times. This first part is often going to take some time because of the working that's required. 1/2 into 2i plus 4j plus 4k. Right? And that simplifies to I plus 2j plus 2k. That's the vector OM. That's one thing that we were looking for. Then they're asking us for the vector MN. MN. How do you find that now? MN. If AN is 3 times NB, they're all in the same line as well. Their directions are also the same. We could say the vectors also have the same ratio. We could say AN vector is 3 times NB vector. And then using this, we could first find the vector AN somehow. Can we do that? AN. Let me think about it. We know that vector. In fact, it's actually done simpler directly from this diagram because we know already that this is 4j. This is 4j. That means AB is also going to be 4j. Right? It's a cuboid. So whatever is this length, that's 4 units. This is also going to be 4 units. Right? So we could say this complete vector AB, what's that? That's 4 times j. Now we know that AN is equal to NB at 3 times NB. What does that mean? We could write it like this in ratio form: AN over NB. That is equal to 3/1. So if AN is 3 parts, then NB is 1 part. And the total is 4 parts. So if the total is 4j, can we say anything about A to N? That's 3 out of 4. So we could say this is 3j and this is 1j. And now that we know that A to N is 3j, let me just write that down here. AN is 3 times j. Can we find the vector MN now? We have to go from M to N. Let's find a path on the diagram that takes us from M to N. We could say, let's go from M to D, or maybe in the other direction. It doesn't matter. You can go here or in the other direction, doesn't matter. One possible path that you could follow could be this, that you go from M to F, and then you go from F to C, and then you go from C to B, and then you reach this point like this. You could follow some other path on the diagram as well. You could also say that's the same thing as saying you go from M to D, and then D to A, and then A to N. Follow any of those paths, and you will get that result. Now, how do we do that? What is DE vector? This complete vector. This is also 4j. This is also 4j, right? It's in the same direction. What about this? Let's actually decide which path you're going to follow. So if you're following this path, for instance, let's see what we know about this path. We have to go from M to this point D first of all. Now, in order to go there, we don't know this direct vector from M to D. I could do something like this. I could say, let's go in this direction here, parallel to that, parallel to DE in this direction, and then go here. How would that work? Let me explain that. This vector is 4 times j. This would be half of that, right? Because M is the midpoint. So that's 2j. But since we're going in the other direction, this is going to be minus 2j, right? In the other direction, it was 4j. In the left direction, it would be negative. And then we have to go this way. This complete vector, do we know something about that? That's the same thing as this. That's 2i. So this complete vector would also be 2i. So what would be half of that? The half of that would be I. And then we have this minus 2k, because in the upwards direction it was 2k. In the downward direction, it will become negative. And then 3j in this direction, and that will give us mn. Let me write that down here. Mn vector, what would that be? We go from m to this point on the left side, that's minus 2j. And then we go in this direction, that's 1i. Right, I is in this direction, that's parallel to that, but it's only 1 unit, so that's plus I. And then in this direction, that becomes minus 2k. And then in this direction, that's plus 3j. You simplify this and see what that gives you. I plus j minus 2k. That's the final result that we get from this. It's very similar to O-level vectors. The only difference is that now this is in 3D. Now this is in 3D. So that's how it would work. Any problems with this? Any questions? No problems? Okay. So now that we are done with this, now the next part, as we saw in the earlier question as well, they were not that complicated. Let's look at this now. Find a vector equation for the line through M and N. How do you do that? That's going to be R equals A plus lambda D. That's the equation of the line that you've got. Now, what's the direction vector? Mn. We have found that already. That's the direction vector. We can write that in column vector form. That's 1, 1, minus 2. That's the direction vector. We can use any one of the 2 points out of M and N as A here, and that will be the equation. What's A? We could say the point OM that we found. Let's use that as A. So that's 1, 2, 2 plus lambda into 1, 1, minus 2, right? These 2 marks were fairly straightforward. That's your final answer for the second part. Then it says, show that the length of the perpendicular from O to the line through M and N is this, right? Again, that's a standard method, perpendicular distance. You need to memorize the steps in this method. I've said that multiple times. How would we do this? We've got a perpendicular coming from O to the line through M and N. We've got the equation of the line, and the equation of the line looks like this. R equals 1, 2, 2 plus lambda 1, 1, minus 2. That's the equation of the line. Now we can think of it like this. We've got a line, we've got this line, and there's a point that is O, that's the origin. We want to find the perpendicular distance from the origin to this point, to this line. We can call this point something. Let's call this point X. Now this point X lies on the line. That means the position vector of the point X is going to be of the same form as the equation of the line. And that's 1 plus lambda, 2 plus lambda, 2 minus 2 lambda. Right? That's the position vector of the point X. Okay. Then we have to put the dot product of this vector and the direction vector of the line equal to 0. Now we already have that. Normally, if this point was something other than the origin, we first had to find that vector. Now in this case, it's the origin, so we have that vector already. All we have to do is put this dot product OX and the direction vector of the line, which we know was MN, the direction vector of the line. This should be equal to 0. Now, what's the OX vector? 1 plus lambda, 1 plus lambda, 2 plus lambda, 2 minus 2 lambda dot MN vector. That is 1, 1, minus 2. Put this equal to 0. And now simplify this. You get 1 plus lambda plus 2 plus lambda minus 4 plus 4 lambda equals 0. Let's simplify this. We get 6 lambda minus 1 equal to 0. And the value of lambda is turning out to be 1 over 6. That's the value of lambda that we're getting. Now we wanted to find the perpendicular distance from O to this line. That's the distance OX. That's what we are looking for. Now we found OX already. That's 1 plus lambda and so on. We can input the value of lambda in that. OX vector, that's 1 plus lambda. That means 1 plus 1 over 6. 2 plus 1 over 6. I'm using this here. And 2 minus 2 over 6. What does that give us? Let's figure this out. This is 7 over 6, 13 over 6, and what about this? 2 minus 1 over 3? 5 over 3, I think, right? 5 over 3. And now we find the magnitude of this and see what that turns out to be. Square root of 7 over 6 squared plus 13 over 6 squared plus 5 over 3 squared. And that would give us the result. Square root of this whole thing. Since you need to show this, you should show some working here. Ideally, just simplify this on your calculator first. Or in fact, there's no working required as such here. Just put this on your calculator to confirm that you do get that answer. 49 over 36 plus 169 divided by 36 plus 25 over 9. $53 over 6, 53 over 6, that's what you wanted. So we got square root of 53 over 6. And that's what you had to prove. That's the perpendicular distance between origin and this line. Makes sense? That's the standard process. There's nothing very complicated here. Let's move on to the next one. That was part C of this question. The next is iteration. The first part is differentiation. You'll just use the product rule of differentiation and then use iteration to do these other parts. And that's it. Okay, all right. So that's all in this paper. Let's move on to the next one now. Paper 3-2. Let me know the questions you want me to do from this paper now. I can see some responses here. So the 3 questions primarily that you guys are asking about, questions 2, 4, and 9. Okay, so this is the one that we will be doing next. Let's have a 1-minute break, then we start with this. In fact, we had a break already. Let's just continue. Let's just continue with this. Okay, May-June 2022, paper 3, variant 2. This is the next paper that we're doing now. Let's do difficult questions from this paper now. Okay. The first one is fairly straightforward. No one has asked about this. Question 2, why? Why question 2? There's nothing complicated here as well. You can actually do this. You'll get a quadratic equation. So do something like this. Apply the double angle identity for cos. So that it becomes 2 cos square theta minus 1. Cos 2 theta can be replaced with this. This equals 3 cos theta plus 2. And that will give you a quadratic equation, 6 cos square theta minus 3 and then minus 2 from the other side. You've got minus 3 cos theta minus 3 minus 2 minus 5 equal to 0. Solve it as a quadratic. You'll get 2 values of cos. Depending on if both of them are between minus 1 and 1, you'll solve both of them separately. Find the basic angle, look at the quadrants, and then solve that. Right? That's not very complicated. You can do that. Okay, after this, I'll move on to the next one. Question 3 is not that difficult. That's just polynomials. You have to make 2 equations using remainder theorem. Solve them simultaneously. Okay, so this is the first question that we'll do from this paper. Question number 4. Equation of a curve is given by this. Y is equal to cos cube x into square root of sine x. It's given that the curve has one stationary point in this interval. Find the x coordinate of the stationary point, giving an answer correct to three significant figures. How do you find stationary points for any function? You find the derivative, put that equal to 0. That's what you would do here. Find the derivative, put that equal to 0. It's a product. You can say this is u and this is v. Okay. So what would dy with dx be then? You can use the product rule. uv dash, that means u as it is, cos cube x as it is, into derivative of this. What I'll do is I'll write it in the power form first of all. So this is cos of x whole power 3 times sine of x whole power 1 over 2, right? That's what the function is. So we keep cos cube x as it is into derivative of this. Apply the power rule, multiply by the power, subtract 1 from the power, so it becomes sine x power minus 1 over 2, multiply by the derivative of sine x, which is cos x, plus vu dash, that means v as it is, which is sine of x whole power 1 over 2, into u dash, that's 3 into cos square x, into derivative of cos, which is minus sine x. That's the result that we get. Let's simplify this. We're looking for the stationary point, right? We put that equal to 0 because we're looking for the stationary point. How do you find stationary points? We put derivative equal to 0. Now let's simplify this. How would we simplify this? We've got one negative power. What I can do is, this is cos cube, this is cos. That becomes cos raised to power 4x. This is negative power. I can write that in the denominator with 2. So it becomes 2 sine x whole raised to power 1 over 2. Okay, what about the second term now? There's a minus there. So we have minus and then 3 cos square x into sine of x whole raised to power 1 over 2 plus 1, that's 3 over 2. Okay. What do we do now? We take this to the other side. Three cos square x into sine of x raised to power 3 over 2. That equals cos raised to power 4x divided by 2 sine of x whole raised to power 1 over 2. Now I can take this to the other side, multiply this there. 2 into 3, that becomes 6, into cos square x into sine x raised to power 3 over 2 and sine x raised to power 1 over 2. When we multiply them, what happens? The powers get added. 3 over 2 plus 1 over 2, right? That will become 2. So we have sine square x from this. And that equals cos raised to power 4x. Okay. And now we have to solve this equation. Take all terms to one side. 6 cos square x into sine square x minus cos raised to power 4x, that equals 0. Take cos square x common outside, and that leaves you with 6 sine square x minus cos square x inside, that equals 0. That means either cos square x equals 0 or 6 sine square x minus cos square x equals 0. These are the two equations that we get from this. What about the first one? We can take square root in both sides. That gives us cos of x equal to 0. Now the interval that we're given is from 0 to pi over 2. That means in the first quadrant only. Now cos is 0 at pi over 2 and then 3 pi over 2. Pi over 2 is not included in this interval, so we ignore that. We have no possible answer inside the given interval. So this is not acceptable. What about the other equation? Now, there are multiple ways of solving this. You could convert cos square to sine square. You could convert sine square to cos square, or you could convert them to tan squared. All of them will work. You can do idea could be that we say it becomes 6 sine square x equals cos square x. Now divide that in this side. So it becomes 6 sine square x divided by cos square x equals 1. So tan square x equals 1 over 6. That's one possible way of doing this. Take square root on both sides, and that leaves you with plus minus square root of 1 over 6. You want an answer in decimals? You can't get an exact answer here. Find the basic angle, and you would get tan alpha equal to square root of 1 over 6. What's the basic angle that we're getting from this? What's the basic angle that? Has anyone done this? Make sure your calculator is in radian mode. Tan inverse of square root of 1 over 6. 0.38. So minimum 4 significant figures in your working. This is not your final answer yet. Although in this case, it would not matter because we're talking about first quadrant. So that will be your final answer as well. Eventually, 3876, that's what we're getting from this. Now, tan is plus minus. That means it could be in any one of the 4 quadrants. All 4 quadrants are possible. However, the interval that we're given is only from 0 to pi over 2. That means we can't go beyond the first quadrant. So whatever is the basic angle, that's our final answer as well. The value of x that we get is 0.388 to 3 significant figures, and that's our final answer. That's the x coordinate of the stationary point. Okay, they only wanted the x coordinate. If they said coordinates, that means that would have meant that we need the y coordinate as well. In this case, we don't. So that's our final answer. That's what we were looking for. Any problems with this? Any questions, anyone? Yes? Yeah, if they said y coordinate as well, you would just input that value of x in the function, and that will give the corresponding y coordinate. But in that case, yes, in that case, put the more accurate number, put this number. Instead of 388, you put 3876. Okay, that was this question. Let's move on now. Question 5 next. You want me to do this? Okay. Just the first part, I assume? Only the graph, right? Only the graph or the next parts as well? Just the graph, I assume. Okay. The second and third parts are standard iteration questions that are fairly straightforward. Okay, let's do this first part. By sketching a suitable pair of graphs, show that this equation has one real root. Now, in this case, they have not given you any interval. Now, for log graph and for exponential graph, a lot of times they do not give you an interval. Okay, so you need to know the standard method for that. For log graph, there's one important point that you always need to draw, and you also need to know about the asymptote of this graph. When do you get the asymptote, and at what point do you have that important point? The function is ln x. Whatever is inside ln, when that is equal to 1, that's the important point. So the important point that we got in this case is when x is equal to 1. What's the corresponding value for? So these are the two functions that we're talking about, right? This is one function that we would be drawing, y equals ln x. And then the other function is a quadratic function, 3x minus x squared. We're starting with the log function, first of all. This is the important point when the inner part of log is equal to 1. That's what we always need to show on the graph. The corresponding y value for this is 0. Okay, let's draw that. This is the y-axis, this is the x-axis. Let's say this is 0, 1, 2, 3, 4, 5. Similarly, on the left side, you've got -1 here, 1 here, 2 here, then -1. Okay, the important point that we have is 1, 0. So this point here. This is one point that we always have to show for the log graph. Whenever the inner part is equal to 1. And then what about the asymptote? Where is the asymptote of this graph going to be? The asymptote of the log function is when the inner part is equal to 0. Now, in this case, the inner part of log is just x. So the asymptote is going to be when x is equal to 0. So x equals 0, that's a vertical line. This line is the asymptote of the log graph. The graph cannot cross this line. It cannot cross this line. This x equals 0 line is the asymptote of this graph. Now, how do we draw the graph? Close to the asymptote, it's either going to go there or there. Now, you need to remember the shape of the log graph. There are 4 possible shapes, right? For both the exponential and log graphs, they could look like this, 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 or this. These are the 4 possible shapes that you can have, roughly, for these 4 graphs. Log graph has vertical asymptotes, exponential graph have horizontal asymptotes. We've got this vertical asymptote, x equals 0. Now, what you have to do is take a couple of points on either side of 1. Take 1 point on the right side. You can try, for example, ln of 2 and see what that gives you. Ln of 2, that's 0.693. So that will be some point here. And that is enough to tell you what the graph is going to look like on the left side of the important point. It's going to go down towards negative infinity, right? So the graph is going to look like this for log. It goes like this on this side, and the left side, it makes an asymptote with the y-axis. That's the log graph. That's the one graph that we had to draw. Yes, exponential also have graphs, of course. This does take time. So if it's a 2-mark question, you will unfortunately end up spending like 4 or 5 minutes on this. I would recommend skip this part initially, do the rest of the parts, and then at the end of the exam, come back to this. Graphs take time, and they are not worth a lot of marks. It's only 2 marks. That's a lot of work for 2 marks. So do the rest of the paper first, and then before you do the most difficult questions, you can come back to this, because these are easy marks, even though they take time, but these are not that difficult, right? But don't do them in the first go. In the first go, when you're doing the relatively easier questions, skip this for later. Not the whole question, just the first part. The second, third parts of this question, they are the easiest parts in this paper, right? You don't skip them. That's the log graph. Now, what about the other one? That's a quadratic graph. What's the shape of this quadratic graph? It's an n-shaped graph, right? The coefficient of x squared is negative. It's an n-shaped graph. What are the x-intercepts? What are the x-intercepts? It's an n-shaped graph. The coefficient of x squared is negative. This is minus x squared plus 3x, right? What about the x-intercepts? We can put y equal to 0 for that. In this case, x-intercepts, finding x-intercepts is quite straightforward. So you can do that quickly. You'll say 0 equals, take x common outside, minus x plus 3. One x-intercept is at 0, the other is at 3. So the graph is going to cut the x-axis at 0 and at 3 again. The maximum point is going to be exactly in the middle. So you can draw a graph that looks like this. If you want, you can find the maximum value as well. Although it's not necessary for 2 marks, you'll just draw a graph like this such that the maximum point is at 1.5, exactly in the middle of the x-intercepts. And the graph looks something like this. That's the quadratic graph. And then you say, there's only one point of intersection. Since there's only one point of intersection, what am I doing? Since there's only one point of intersection, there's only one root. You can highlight that point here, and say there's only one point of intersection. Clearly, writing this is important, because that then means that there's only one root. Make sense? That's what the graphs are going to look like. You would label them appropriately. This is 3x minus x squared. The other one is ln x. And that's it. That's the first part. The next 2 parts are straightforward after that. Let's move on to the next one. Okay, what about the next one now? This was question number 6 from this paper. It's 3, 2, right? Okay, let's move on. No, am I looking at something else? Okay, I'm sorry. I was looking at the wrong poll earlier. Did no one ask about 5 earlier? Why did we do that? Okay, just give me a second. I'll be back. Okay, so the next question from this paper is question number 6. That's okay. So what I'll do is I'll just do the separating the variables part here because the rest of it is straightforward, right? So maybe the problem is while separating the variables, the rest will be easy after that. How do we separate the variables first of all? How do we separate the variables? Let's think about that. dy is on the left side, so we want y on the left side. And x terms on the right side. So we can do something like this. We can say dy equals x e raised to power y minus x dx. Okay, that's the first thing that we can do. Now we want this y on the left side. How can we do that? Using indices rules. So basically, if you have a raised to power x over a raised to power y, we can write that as a raised to power x minus y. If you have a raised to power x minus y, we should be able to write it like this. We can do the reverse working like this as well. So what we can do here is we can say dy equals x as it is, e power y minus x. We could write that as e power y over e power x. Right? Using those indices rules, we could break it down like this. And now it becomes, you take e power y to the other side, 1 over e power y, dy. On this side, you have x over e raised to power x dx. The variables are separated. Now you have to integrate both sides. How do we integrate them? On the left side, we can write it as e raised to power minus y first of all, and then just use the rule that we've got for e power something. On the right side, we have a product. For that, we would have to use integration by parts, right? Integrate this directly. For this, use integration by parts. You'll have plus c, find the value of c using the point that you're given. And that's it. You'll find an expression for y in terms of x. Okay. After this, I assume that you can do this. Okay. Yes, on the right side, it's a product. You have to integrate that by parts. Okay. All right. So that was 6. Let's move on. 7 is straightforward. You just have to do implicit differentiation. In the next part, it says the tangent is parallel to x-axis. So you put dy over dx equal to 0. You'll get an equation. Solve that simultaneously with this original equation to find that point, right? Then you have partial fractions and then integration from that partial fractions. That's a proper fraction. So you'd have to use ln rule once you've integrated, and possibly the tan inverse rule as well, depending on what you get from second fraction. You might have to split the numerator there as well. We've done multiple questions like that already. Okay, so the next question that most of you are asking about is question number 9. Let's do this. Question 9. It says lines L and M have these vector equations respectively, where A and B are constants. Given that L and M intersect, okay, so we are given that L and M intersect. What does that mean? We're given that L and M intersect. It means when we get three equations, and we solve two of them simultaneously, the third one should also satisfy. The third one should also satisfy. Okay? Because that would mean then that the lines intersect. So all you have to do is equate these two equations. So we could write them like this. First of all, in the column vector form, -1, 3, 4, -1, 3, 4, plus lambda 2, -1, -1, and the other one, that's R equals 5, 4, 3, plus mu A, B, and 1. We equate both of them. -1 plus 2 lambda, 3 minus lambda, 4 minus lambda. That equals 5 plus A times mu, 4 plus B times mu, and 3 plus mu. We get three equations from this. This is equation 1, equation 2, equation 3. Solve any two of them simultaneously. We can solve the first two. -1 plus 2 lambda. That is equal to 5 plus A times mu. That's one equation. The other equation is 3 minus lambda. That equals 4 plus B times mu. Let's solve them simultaneously. How can we do that? We can do substitution. If we make lambda subject from here or mu subject from here, we will get fractions, right? To avoid fractions, you see, in the other equation, there's no coefficient for lambda. So it will be easier to make this lambda the subject. That will avoid fractions. So I can take lambda to the other side, to the right side, bring everything else to the left side. 3 minus 4, that's -1. Minus B times mu. So lambda equals this. Lambda equals -1 minus B times mu. Put that in the other equation. And that gives us -1 plus 2 lambda. No, let's actually input lambda equal to that. -1 plus 2 into -1 minus B times mu equals 5 plus A times mu. Right? Let's simplify this. -1 minus 2 minus 2B mu. That equals 5 plus A times mu. Okay, let's just confirm if the working seems okay. -1 plus 2 into -1 minus B mu equals this. That's -1 minus 2 minus 2B mu. Okay, that's okay. We have to make mu the subject now. I can take the mu terms to the right side because that will make them positive. Plus A times mu. 5 goes to the other side. And -3 minus 5, that becomes -8. Let's take mu common. That leaves us with 2B plus A inside. That equals -8. And then okay, sorry, just end this call. Okay, -8 equals -8 over 2B plus A. That's the value of mu that we get. So lambda equals this and mu equals this. That's what we were looking for, right? We've got the values of lambda and mu. Now it says the lines L and M intersect. Now, since they intersect, these values must also satisfy the third equation. So we can input these values in the third equation now and see what that gives us. The third equation is 4 minus lambda equals 3 plus mu. Let's input those values of lambda and mu. We get 4 minus -1 minus b mu. That equals 3 plus -8 divided by 2b plus a. This is what we end up getting. Let's simplify this a bit. we get 4 plus 1 plus b times mu, that equals 3 minus 8 over 2b plus a. I can take this 3 to the other side as well. 5 minus 3, that's 2. 2 plus b mu, that equals minus 8 divided by, why do I have mu there? Okay, I'm sorry, I did not find the corresponding value of lambda there. This is still in terms of mu. Let's first find the value of lambda as well in terms of a and b. We did not find that there. Minus 1 minus b into mu, that would be minus 8 over 2b plus a. Okay, let's simplify this. This gives me minus a plus 8b divided by 2b plus a. That's the value of lambda that we're getting. So now when we input this here, let's actually input that value of lambda as well. What I'll do is I'll change the version on the left side. The right side remains the same. On the left side, I would have 4 minus lambda. So that means 4 minus 1 plus 8b divided by 2b plus a. Let's simplify this. We get 4 plus 1 minus 8b over 2b plus a. Right? What do we get now? We can take this 3 to the left side. That becomes 2 minus 8b divided by 2b plus a. That equals minus 8 over 2b plus a. Now we want to get rid of the fraction. We've got 2b plus a here, 2b plus a here. To get rid of the fraction, I can just multiply the whole thing by 2b plus a. That will eliminate the fraction. So that will become 2 into 2b plus a minus 8b on the left side and minus 8 on the right side. Let's simplify everything. We want this at the end, constant on the right side, b and a terms on the left side. Let's simplify this. We get 4b plus 2a minus 8b equal to minus 8. And that's giving me minus 4b plus 2a equal to 8. And now we can simplify this. We want 2b here. Let's divide the whole equation by minus 2. Right? Change the signs first of all, and then divide by 2 to simplify it. Or you can say divide by minus 2 directly to simplify this equation. What does that give me? 4b minus 4b over minus 2, that becomes 2b. 2a over minus 2, that becomes minus a. 8 over minus 2, that becomes minus 4. This was minus 8, sorry there. So it's minus 8. Minus 8 over minus 2, that becomes 4. And that's what you wanted to prove there. 2b minus a equals 4. That's the equation that we wanted. Okay, quite some algebra, but you get that answer eventually. Does this make sense? Any problems with this? Any problems, anyone? Yes. So it's paper 3. It's fair game. It can happen in paper 3. For 4 marks, you had to do all of this. Yes. The concept was not that difficult. It's only the algebra that was difficult. Is it confirmed about CS paper, by the way? I was getting some messages last night as well. Did it actually turn out to be the same paper? I think Cambridge just gave up at this point. Okay, so 2b minus a is equal to 4. That's the equation that we had to prove in the first part. Now it says, given also that L and M are perpendicular, find the values of a and b. Now, if they're perpendicular, that means their direction vectors, their dot product should be equal to 0, right? These are the direction vectors. This and this, their dot product should be 0. 2 minus 1, that's one vector that we've got. 2 minus 1 dot A, B, and 1. A, B, and 1, that's the other vector. This dot product should be 0, so that gives us 2A minus B equal 2A minus B minus 1 equals 0, and that's another equation that we've got. So now these are easy 4 marks. The first 4 marks were difficult, but now these are easy 4 marks because this is one equation that we're getting. Another equation was there in the first part already. We'll just solve them simultaneously and get the values of A and B from this. Okay, this is ongoing on here. I'll just do it silently. It's just simultaneous equations. Then we do the next part after that. Okay. Part C now says when A and B have these values, find the position vector of the point of intersection of N and M. Now these are also again easy 2 marks. So if you've done the first part, you've already done all of this work here. You equated the 2 equations, you found the values of lambda and mu in terms of A and B. Now that you have the values of A and B, you can input them here in either the equation for mu or the equation for lambda. And that will give us their value, right? For example, if I say mu is equal to minus 8 over 2b plus a, let's input that in this equation. Or in fact, that equation has a and b as well here. It will become easier to just put that in lambda because that will be easier to evaluate then for the position vector. Lambda is equal to minus 1. Let me just write that here. Lambda equals minus 1 plus 8b plus 8b over 2b plus a. That's the value for lambda that we had, minus 1 plus 8b over 2b plus a plus 8b over 2b plus a. Now we've got the values of a and b. Let's input them here. Lambda becomes minus 1 plus 8 into 3 divided by 2 into 3 plus 2. You can see what that value turns out to be. What's the value of lambda that we get? Value of lambda? Does anyone have this? Eight.
So 2.
2. Okay. Lambda turns out to be 2. If lambda is 2, then you can just input that in this equation now, and that will give you the corresponding point that you're looking for. Minus 1 plus 2 lambda. So what's the point now?
सर आपकी आवाज नहीं आ रही।
Was 1, 4 minus 2 is 2. That's the position vector of the point of intersection. Okay, so the first part required some working, but then the other two parts, these were fairly easy 6 marks, right? And that's it. That was the vectors question. No problem with this one. Okay. The argon diagram, greatest value of argument. Yes, we'll do the third paper as well because today is the last past paper class that we're having. Let's just get the most out of it. I don't have another class after this as well, so I have time. Let's do that. Okay, what about question number 10? Is there a specific part in question number 10 that you want me to do? Any specific part of this? I think we've done many of these. Let's move on to the next one. The next paper, because there are a lot of questions that you guys have from that paper. So let's move on to the next one. This is a standard complex number question that you get. You can use sum of roots formulas for this as well. Using the sum of roots formula, this 4-mark question can be done in like 3 steps. So that will make it fairly straightforward. Then you have argon diagram and greatest value of argon is the. Let's move on to the next paper, paper 3.3. Okay, so what about this paper now? Paper 3.3. So just give me 1 minute, 1 or 2 minutes, then we start with this paper. May June 22, paper 3.3. So from this paper, you're asking about questions 3, 4, 5, 8, 10. Okay, so I'll have a look at these questions, the ones that are not that difficult. We will just, I'll just give you a hint on something. That's it. Part B. That's a standard complex number method. You should know that. There's nothing complicated about it. If you know the standard method, there's nothing new in this. You have one root given, that's this. That's minus 1 plus under root 7 iota. This is one root. Since the equation has all real coefficients, another root is going to be conjugate of this minus 1 minus under root 7 iota. Then one way to do this is using long division. That's what the standard method is. You make 2 factors out of this. So one factor would be x plus 1 minus under root 7 iota, and the other factor would be x plus 1 plus under root 7 iota. Multiply these 2 factors, get a quadratic factor, then do long division, divide this polynomial with this quadratic factor that you would get from this. You'll get a linear factor, and from that factor, you'll get the third root. That's one possibility. But a quicker way of doing this is using the sum of roots formulas. You have that polynomial. That polynomial is 2x cubed plus 3x squared. Let me write that here. 2x cubed plus 3x squared plus 14x plus k equals 0. Sum of roots of this equation, that is given by minus b over a. So that's minus 3 over 2. That's the sum of roots. So you could say one root is minus 1 plus under root 7 iota. The second root is minus 1 minus under root 7 iota. The third root, let's call that x3. That's what you want to find out. The sum should be minus 3 over 2. And you can find the value of x3 from this. This and this, they get cancelled. Minus 1, that becomes minus 2 plus x3 equals minus 3 over 2. And the third root, that turns out to be 2 minus 3 over 2. That's 1 over 2. And that's your third root. One root is minus 1 minus under root 7 iota, and the other is 1 over 2. These were the 2 roots that we were looking for. Okay. The other method is using division, long division. Uh, I told you about that as well. You could also do that. Okay. All right. Just 1 minute now, and then we start with this next paper. Okay, let's resume. Let's resume and look at this next paper now. June 2022, paper 3, variant 3. Let's do this now. Okay, so let's have a look at some questions from this paper. Question number 1, that's just modulus. It's in terms of A. You can do that. 2 is just a trigonometric equation. We just apply the compound angle identity on this. And then it can be converted to, you'll take all terms to one side. You have cos theta, cos 60, and then it can be converted to tan. Sine on one side, cos on the other side. It can be converted to tan easily after that, after you have expanded it. That's not that difficult. The third question, this is also not complicated. It's a simple log question. You have to write it as a quadratic, and then you just solve that. Okay, next part. All right, so maybe the second part could be a problem. Let's have a look at this quickly. Okay, how do we solve this equation? Double angle nahi, compound angle. This is theta plus 60, theta minus 60. So cos A minus B, the compound angle identity. Yeah. And then you can convert that to tan after that. Okay, let's have a look at this. Question number 3. Show that this equation can be written as a quadratic equation in X. How do we do that? Bring all log terms to one side first of all. So it becomes log of 2x plus 1 base 3 minus 2 log of x minus 1 base 3. On the other side, you've got 1. Now you can use the division log here, but before that, you'll have to take this 2 to the power, right? You want only 1 multiplying outside, no other number. So you can take 2 to the power, so it becomes log of x minus 1 whole squared with base 3. And that equals 1. Use the division law, and that gives you log of 2x plus 1, log of 2x plus 1 divided by x minus 1 whole squared base 3. And that equals 1. Now to get rid of this log, what we can do is we can take 3 to the other side, make it the base of 1. So you have 2x plus 1 over x minus 1 whole squared equals 1. And that's 2x plus 1 equals x minus 1 whole squared. In the first part, they said, show that it can be written as a quadratic equation. This is a quadratic equation. You can leave it like this. And that's it. Okay. Same basis can be written as 1 log. No. We are applying division log here. We're not just writing that as a single log. We're applying the division law. And yes, for applying the division law, the bases have to be the same. If the bases are different, then we cannot apply the division law. This is minus outside log. Inside log, it becomes division. But yes, that's a condition that base should be the same for both of them. You won't get different bases in the same question. That's not part of your syllabus. It will always be the same basis. Okay. All right. What do we do now? We have to just show this. It can be written as a quadratic equation. We have done that. That's it. That's what we had to do in the first part. Or since they're saying quadratic equation, it might be a good idea to actually write it in a standard form. Although it doesn't say that in the question, but let's just do that anyway because we have to solve that equation in the next part. Let's write it in the standard form. How would you do that? This expands to x squared minus 2x plus 1. And then that will become x squared minus 4x. 1 minus 1, that becomes 0. So x squared minus 4x equals 0, right? It simplifies to this equation. Okay. x squared minus 4x equals 0. Any problem with this? No? Okay. Let me just check the working again. This was squared here. That equals 1 whole squared, 2x plus 1 divided by x minus 1 whole squared equals 1. 3 goes to the other side. Okay, I'm sorry. So that's an error there. When we took 3 to the other side, I said that when I was explaining, I said that verbally, but I did not actually write that. It becomes 3 power 1 on the other side, right? So it's 3 power 1 there. It's 3 power 1 there on the other side. So that actually becomes 2x plus 1 equals 3 into x minus 1 whole squared. And now if you simplify this, that gives you 3 into x squared minus 2x plus 1. And on the right side, you get 3x squared minus 6x plus 3. And that finally simplifies to 3x squared minus 8x plus 2 equal to 0. Okay? Is that okay now? That's the first part. Now it says, hence solve this equation. Now, what has changed in this equation? In the first part, the equation looked like this. Let me write that here. Log of 2x plus 1 base 3. That was equal to 1 plus 2 log of x minus 1 base 3. Now, what has changed? What has changed? You can see x has been replaced with 2y. Here as well, in place of x, you've got 2y, right? So in that equation that we had here, x squared, all you have to do is, in that equation, since you're solving this equation now, replace x with 2y, right? So you replace x with 2y. So that equation would become 3 into 2y whole squared minus 8 into 2y plus 2. And that's the equation that you now need to solve. Let's see what we get from this. 0 equals 3 into 4y squared minus 16y plus 2. And that simplifies to 12y squared minus 16y plus 2 equals 0. We can simplify this, divide the whole thing by 2. 6y squared minus 8y plus 1 equal to 0. Can we factorize this? The question says 2 decimal places. That is a hint that you cannot factorize this. You use quadratic formula. Just input values in the quadratic formula. Minus into minus 8 plus minus square root of minus 8 whole squared minus 4 into 6 into 1 divided by 2 into 6. And then you can write this directly in the on your calculator and get the result from that like this. You go to menu, equation solving function, polynomial, degree to 6 minus 8 and 1. And that's given me y equal to 1 point. We want 2 decimal places in the final answer. So 1.19, that's one possible answer. And 0.1396, that rounds off to 140. That's another possible answer that we're getting. Now, whenever you get multiple answers, we should always check if both of them satisfy the equation or not, or is there any information in the question? If there is any information in the question that requires us to ignore one of the answers, let's check that. So we have to solve this equation. The question says, give your answer. The question statement is always going to be very precise. They're saying answer, that it's not a plural, it's a singular. That means you want a one answer. You can only have one answer. Now, which one of them are we going to accept? Let's think about it. If y is 1.19, let's check if any of these logs become negative. This is 4y plus 1, that cannot become negative. What about this? 2 into 1.19 minus 1 inside the log, that's positive. So the first one is okay. So that's most likely correct then. What about the other one? 0.140. Let's just confirm that does not work. You can input that here. 2 into 0.140 minus 1. What do you get from that? You get something negative, right? 0.28 minus 1, that's minus 0.72. That's a negative number. Inside log, you end up getting something negative with this value of y. So that's not possible. You clearly have to cancel out that answer, cross out that answer, write that that's not possible. And this is the only possible answer, 1.19. Okay, if you do not ignore this answer, you lose 1 mark. Okay, that was question number 3. Let's move on now. The next one is question number 4. What about this? This is a curve. It has 2 stationary points. You have to find the derivative and show that it can be written in this form, where a and b are constants. Use product rule. You should get this from that. Then they're saying, hence find the exact x coordinates of the 2 stationary points after that. Doesn't that look relatively straightforward? Is there a specific issue with this? Is there any specific problem with this? Okay, let's try to do it quickly. Let's try to do it quickly and see what we get from this. Okay, I'll try to be a bit quick now. Y equals e raised to the power minus 4x into tan x. It's a product. Apply the product rule. This is u, this is v. uv dash plus vu dash, just apply that. dy over dx. What does that turn out? U as it is, that means e raised to the power minus 4x as it is, and derivative of tan, which is secant square x, plus tan x as it is into derivative of e power minus 4x, that will be e power minus 4x into minus 4. Let's simplify this. They have e raised to the power minus 4x common outside and secant square common as well. Okay. So all right, so that's interesting. So we've got tan x here, that was tan there. This is what we're getting until now. Okay, let's think about it. We can take e power minus 4x common. That's one thing that we can do right away. Let's take that common and see what that leaves us with inside. We have secant square x minus 4 tan x left inside. Now what we want at the end is, we don't want any tan here. You see, there's no tan in the final result. There's actually a sine 2x. Now, where does that come from? Sine of 2x. And there's a secant square that is outside. Okay. So how do we think about this? We can write tan as sine over cos first of all. Let's eliminate that. Eliminate tan and see what that gives us. That gives us sine x over cos x. And then, have we missed anything here? E raised to the power minus 4x into secant square x plus tan x into e raised to the power minus 4x into minus 4. That's okay. So now we want to get rid of tan from here. So one idea could be, why do we have double angle here? Okay, so let me just work backwards a bit. Sine 2x, that has to come from 2 sine x cos x. So we want 2 sine x cos x appearing here somehow. Okay. 2 sine x cos x, product of sine and cos. Okay, yeah, now that makes sense. So we write that as sine over cos first of all. We write that as sine over cos, and now we try to simplify this a bit. Let's take LCM, and that leaves us with cos x in the denominator, cos x into secant square x, or in fact, a quicker way of doing this could be that you say secant is reciprocal of cos, right? You can write this as 1 over cos square x, and that will make things simpler. 4 sine x over cos x, right? Secant can be written as 1 over cos, right? So that's 1 over cos square x. Now we can take LCM. What's the LCM going to be? Cos square cos. The higher power is the LCM. That's the denominator, cos square x. In the numerator, we get 1 minus 4 sine x into cos x. And that's where this was coming from. Sine 2x is 2 sine x cos x, right? So now what we can do is we can write it in that form. E raised to the power minus 4x into 1 minus 4 sine x cos x. What would that be? If sine 2x is 2 sine x cos x, we can multiply both sides by 2. Then 2 sine x 2x, that should be 4 sine x cos x. Right? So this becomes 2 sine of 2x. right? We can replace this thing with 2 sine x 2x using that identity. Now in the denominator, we have cos square x. So we're almost there now. We've got this form inside. We want secant square x as well. What we can do for that is cos square, that's the reciprocal of secant. We can take that to the numerator now. That will become secant square. So we have e raised to power minus 4x into secant square x into 1 minus 2 sine of 2x. And that's what we wanted. You can write it in that form now. They've written secant square first, e power minus 4x at the end. It doesn't matter. It's multiplication. We could write anything first, anything at the end. So we can say this is secant square x multiplied by 1 minus 2 sine 2x times e raised to power minus 4x squared. That's the derivative that we get. It turns out it was actually quite tricky thinking about how to convert to that form. That was a double angle there. So we had to think about how to convert to that form. Does that make sense? Any issues with this? Any problems? Any problems, anyone?
Sir, e power minus 4x.
Minus 4x, yeah. So there's no square there, I'm sorry. Just for minus 4x, yeah. That's the final answer. Okay. All right, so that was question number 4, part A. Okay, we have another part. Hence, find the exact x coordinates of the 2 stationary points. Now we've got the derivative. dy over dx, that is equal to secant square x into 1 minus 2 sine of 2x e raised to power minus 4x. For stationary points, we put the derivative equal to 0. So 0 equals secant square x into 1 minus 2 sine of 2x into e power minus 4x. Now it's a product. We can put each part equal to 0 separately, right? If the product is equal to 0, that means either this is equal to 0 or this is equal to 0 or this is equal to 0. What do we get from that? Secant square x, that equals 0. 1 minus 2 sine of 2x equals 0, and e raised to power minus 4x, that equals 0. Now, what about the first one? Secant square x equal to 0. What do we get from that? Secant is reciprocal of cos, so we can say 1 over cos square x, that is equal to 0. Now, that becomes that cos square of x, if we take reciprocal on both sides, that is equal to 1 over 0. Now, does that make sense? We can actually remove the square initially as well to make things a bit more simpler. Secant square x equals 0 means secant x is equal to 0. That means 1 over cos x is equal to 0. And then cos x equals 1 over 0. Now, that does not make sense. Cos cannot be undefined. Cos is not undefined at any point. Tan is undefined at pi over 2, at 3 pi over 2. But cos is between minus 1 and 1. So we don't get anything from here. This equation does not give us anything. This last equation as well, that's also not going to give you anything, because e raised to power anything can never be 0. Any positive number raised to power anything can never be 0. If you try taking log on the right side, you'll get log of 0, which is undefined. So you don't get anything from that as well. So the only equation that you're left with, is the middle one. So what does that give us? 1 minus 2 sine 2x equal to 0. 2 sine 2x equals 1 over 2. No, 2 sine 2x equals 1. And then sine 2x, that equals 1 over 2. Now we want to find the x coordinates of the 2 stationary points. The interval is from 0 to pi over 2. Right? That's the interval that we're given, from 0 to pi over 2. Now that's the interval for x, right? interval for x is from 0 to 𝗑/2 with 0 included and 𝗑/2 not included. Okay, we can use a substitution, right? We say let a equals 2x, then sine of a equals 1/2. What's the interval for a going to be? When x is 0, a is also 0. When x is 𝗑/2, a is pi. A is supposed to be between 0 and pi. Now we find the basic angle. Sine alpha equals 1/2. When is sine 1/2? At 𝗑/6. That's the basic angle that we get. Think about quadrants. Which quadrants can we be in? Sine is positive. That could either be in the first quadrant or the second quadrant. Basic angle could either be here or it could be here. The interval for A is 0 to pi. That means we have to consider both quadrants. A could either be equal to 𝗑/6 in the first quadrant, or it could be equal to pi minus 𝗑/6 in the second quadrant. Put that substitution back. 2x equals 𝗑/6. 2x equals 5 𝗑/6 from here. X equals 𝗑/12 or x equals 5 𝗑/12. These are the two x coordinates that we were looking for. And that's your final answer. Make sense? Any issues with this? No problems? Right? Okay, let's move on. Let's move on to the next question. Okay, so the next one is question number 5. Okay, what about this now? Show on an arc diagram with origin O the points A, B, and C representing the complex numbers U conjugate minus U respectively. State the type of quadrilateral formed by the points O, A, B, and C. Okay, let's represent those points on an arc diagram. Remember, on an arc diagram, you need to make sure on both axes you're using the same scale. Whatever is 1 unit on one axis, it should be the same on the other axis as well. You will be measuring this using a ruler, okay, so that it turns out to be the same scale on both axes. Okay, Anas, let me go back to that after this. Origin is here. This is the origin. The point U is 3 minus iota. Where would 3 be? This is 1, this is 2, this is 3, this is 1, 2, 3, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3. Okay, let's mark those points. U is 3 minus iota, 3 on the right, iota, 1 down. That will be somewhere here. Let's say this is U. Let's mark that. U conjugate, what's U conjugate going to be? The imaginary part will change sign, so it becomes 3 plus iota. And then U minus U conjugate, what would that be? 3 minus iota minus 3 plus iota. That gives you minus iota, that's minus 2 iota. Right, that's U minus U conjugate. So U conjugate is 3 plus iota. That will be this point here. This is U conjugate. This is the origin. That's already there. And then U minus U conjugate minus 2 iota. That's this point here. Now they're saying what's the quadrilateral formed by the points O, A, B, C. We have to name that quadrilateral. We have to first represent these points. We have done that. They're calling these points A, B, and C respectively. Let's write those point names here instead. So this is O, the origin. And then U was represented by A, and then this was B, and this is C. What's this quadrilateral? This, 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 and this. It's a parallelogram, right? Slant diamond. What shape is that? Slant diamond. That's a parallelogram, right? Yes, you should label the points. Otherwise, how would the examiner know what's the point A, what's the point B? You should label them like this: A, B, C. Even if you do U conjugate minus U, that will also be acceptable. But one of these should be done. Either write A, B, C or U conjugate and U conjugate minus U. Okay. Now, what's the parallelogram? What's the quadrilateral? That's parallelogram, right? Opposite sides are parallel and equal. That's what you write there. That's a parallelogram. The point C is minus 2 iota. 3. Okay, I'm sorry. You're actually right. You're actually right. I'm sorry about that. I did it the other way around. It was written as U conjugate minus U. I did U minus U conjugate. It's the other way around. So it's actually U conjugate minus U. So that's U conjugate minus U instead. So that's 3 plus iota minus 3 minus iota. And that gives us 2 iota. So that point C should be up there then. This is point C actually. Okay, if that's the point C, what's the figure that we get now? It's still a parallelogram. We get this quadrilateral, right? This is also a parallelogram. So that's the result that we've got. Okay. Yeah, sorry about that. It was supposed to be 2 iota. Okay. Let's move on to the next part. U conjugate over U, you can do that. Multiply and divide, divide by the conjugate of the denominator. Simplify that. That's pretty straightforward. By considering the argument of U conjugate over U, or otherwise prove this. That's again a standard question that we see on complex numbers. You'll have to use the property of arguments. When two complex numbers are divided, their arguments get subtracted, right? When two complex numbers are divided, their arguments are subtracted. That's the property that you would use here. What I'll do is I'll just use the answer of the first part to just tell you about the third part of the second part to tell you the answer about the third. Tell you about the third part. I'll do this on my calculator directly. You can use this for verification only. If you write down the answer directly in the exam, you get 0 marks for that. No marks without working. But since I want to save some time here, I'll just do this on the calculator directly. It's U conjugate, that's 3 plus iota, divided by U, which is 3 minus iota. So when you do this, eventually you would get 4 over 5 plus 3 over 5 iota. Okay, you have to do the working, of course. And this is the result that you would get from that eventually. Okay, so let's assume that you've got that. Now, what about the next part? They're saying by considering the argument of U conjugate over U, prove this thing. Now, whenever you have an equation like this, you have to use that property that we have for argument, that when two complex numbers are multiplied, the arguments are added, and when two complex numbers are divided, the arguments are subtracted. Okay. So in this case, we could say argument of U conjugate over U, that should be equal to argument of U conjugate minus the argument of U. That's the property that we would use, and we would get that form somehow. Now, how would you do that? You would write down the 3 complex numbers that you have. U conjugate over U, that is 4 over 5 plus 3 over 5 iota. And then the other 2 numbers, U conjugate, that was 3 plus iota. 3 plus iota. And U was 3 minus iota. Let's find the argument for each one of them. How can we do that? Let's do that for u conjugate over u. It's in the first quadrant. It's in the first quadrant. Right? It's in the first quadrant here. So whatever is the basic angle, that's going to be the argument as well. Tan alpha is 3/5 divided by 4/5. That's coming out to be tan inverse of 3/4. Now they want exact values here like this, right? So just leave it like this, tan inverse of 3/4. It's in the first quadrant. So it's in the first quadrant. The argument is going to be the same as that. The argument of w, the argument of u conjugate over u, we can say that's just this tan inverse of this. Okay, it's in the first quadrant. This is also in the first quadrant, 3 plus iota. Real part is positive, imaginary part is positive, so that's also first quadrant. So we can say tan of alpha, that is equal to 1/3. And the argument of u conjugate, that turns out to be tan inverse of 1/3 from this. And then the last one, find the basic angle from this as well. Tan alpha equals 1/3. Now in this case, this is not the first quadrant. 3 minus iota. So right and down, that's the fourth quadrant here. We can find the basic angle. First of all, the basic angle is tan inverse of 1/3. But now since this is in the fourth quadrant, we have to go like this in the negative direction. So what's the angle going to be then? What's the argument going to be then? We'll say the argument here in this case for u is minus tan inverse of 1/3. That's negative. Okay, so we've got these arguments. That's what we had to do here. We found these arguments, and now we can just use that identity that we know about. Argument of u conjugate over u, that should equal argument of u conjugate minus argument of u. Now, while finding the arguments, you can, skip some of this working. I've shown a lot of working here just to make sure that you understand, but in the exam, you could, for example, write down this argument directly, this argument directly. For this one, I would recommend first find the basic angle because that's not in the first quadrant anymore. Find the basic angle and then you put a negative sign with that. So you could save some, working there, but that's what you would think of in your head. Now just input values here. This gives you that tan inverse of 3/4. That should equal tan inverse of 1/3 minus tan inverse of 1/3. Now minus becomes plus, and you get 2 tan inverse of 1/3 on the right side. That equals tan inverse of 3/4. And that's what we had to prove there. That's our final answer. Make sense? Any issues with this? That's the standard method that we use for problems like these. Whenever they ask you to solve them, is to show an equation like this, tan inverse of something, this is what we do there. Is that all right? Any problems? The general rule is, so a lot of people ask about if a certain method is acceptable, if another method is not acceptable. Every method that is mathematically correct and you show working for that in the exam, that is acceptable. Okay? Any method that you show in the exam for which you show complete working, that is acceptable, no matter if it's part of your syllabus or not part of the syllabus. For example, the common questions are in polynomials. In polynomials, you can use synthetic division if you want. That's perfectly okay. In complex numbers, sum of roots, product of roots formulas, you're allowed to use them. You can use them. In complex numbers, that de Moivre's theorem, I don't know how to pronounce that correctly, that, simplifies the powers in cos theta plus iota sine theta form. That's also allowed. You can use that. Everything is allowed that's mathematically correct and makes sense, and you show working for that in the exam, unless there is some marking scheme or some examiner report that explicitly says that this method is not allowed. I don't know of any such method that they have mentioned in any examiner report or any marking scheme that it's not allowed. As long as you're showing working, that is acceptable. Okay. All right. So there was a question here. There was a question here. What was that question? Okay, so this was 1 over cos square, right? So this was 1 over cos square. When you bring that to the numerator, it becomes secant square. So cos was in the denominator. When you bring cos to the numerator, that will become secant. It doesn't matter if you write that outside or inside. It's just multiplying, right? So that becomes secant. So it's just because cos and secant, they're reciprocal of each other. Okay, there was another question that I missed earlier. Can we just equate 1 minus 2 sine 2x equal to 0 in the second part of this? Here, just equate this to 0, ignoring the others. Yes, in this question you can do that. If you know for sure that the others are not going to give you any possible answers. And yes, you could do that in this case. But I would still recommend that you stay safe in the sense that you write this down and then you say this is not possible, right? Just write that down, that you get no solution from that. In this question, if you don't show working and you write that equation, of course you don't get any marks because the equation is already given there. If you write that down directly, you don't get any marks for that. Marks are primarily for this step. You have to write this down. Examiner needs to know that you're using this property here. Okay, if the examiner does not see you using that property, then no, you don't get any marks for that. Okay, in this case as well, yes, if you write down the answer directly, you get 0. You get 0 out of 3. Even though the answer is correct, there's no method, you don't get any marks for that. Okay, you don't get any marks for that. Overall in A-levels, it varies every year. There's no one fixed number that you need to get an A star or an A. But on average, it's generally around 86%. So it depends on the difficulty of the papers, of course, but generally it's around 86% for an A star and around 76-77% for an A. That's where the threshold generally is. That's the average threshold. Okay. 86%, that will be around 214 out of 250. And then for an A, you just subtract 25 marks for that. So probably around 189 something, 189, 190, somewhere around that, you have an A. That's the average. It, of course, depends on the difficulty level and the threshold in your variants. But that's what the average generally is. Okay, let's move on now. Let's move on to the next question. Question number 6. Okay, what about this? That's relatively straightforward. You've got parametric equations, you differentiate each one of them separately, and then you show that. Okay, I think the first part is fairly straightforward. I will skip that. Equation of the tangent of the curve at the point where y is equal to 0. You'll put y equal to 0 here. Find the corresponding value for t from that, and then write down the equation of tangent. That's not that difficult. I'll skip that. Question number 6 is okay. 7 is just partial fractions and then binomial. Let's skip that as well. Okay, question number 8. That's what most people are asking about. Let's have a look at this next. Question number 8 from this paper. It says at time t days after the start of observations, the number of insects in a population is n. The variation in the number of insects is modeled by a differential equation of this form, where k is a constant and n is a continuous variable. It's given that when t is equal to 0, n is equal to 100, solve this differential equation, obtaining a relation between n, k, and t. Okay. So how do we do that? We have that differential equation, dn over dt. When you have these constants here like this, k, it becomes a bit complicated sometimes. Kn raised to power 3 over 2 into cos of 0.02 times t. Okay, now how do we solve this differential equation? First of all, we have to separate the variables. Take dt to the other side, bring n to the other side, so that you get 1 over n raised to power 3 over 2 dn equals k into cos of 0.02 times t dt. Now, for k, it doesn't matter. You can keep it here or take it to the other side. It doesn't matter. Generally, it's easier if you keep it in the numerator rather than taking that to the denominator. Just keep it here. Why would you want to take that to the other side? The denominator, that will give you a fraction. You would generally try to avoid fraction. That simplifies things. Now we integrate both sides. How do you integrate the left-hand side? We can write this as n raised to power minus 3 over 2. What about the right-hand side? K is a constant that remains as it is. Integration of cos is sine, so we get sine of 0.02t divided by 0.02 plus c. How do you integrate this? You can use the power rule here as well. N raised to power minus 3 over 2 plus 1, that becomes minus 1 over 2 divided by the new power minus 1 over 2. That's the integration on the left side. Right? And that's the integration part done. 0.02 is in the denominator. You can bring that to the numerator. You can say 1 divided by 0.02. That's 50. So you could write this as 50 k sine of 0.02 times t. Simplify the left-hand side as well. You can bring this to the numerator. It becomes minus 2n raised to power minus 1 over 2 equals 50k into sine of 0.02t plus c. We need to obtain a relation between n, k, and t. They have not specified that you want any one particular variable, the subject. It doesn't specify that. So all you have to do is input any values that are given in the question. Now it's given that t is equal to 0 when n is equal to 100. Let's put that here. T0 and n 100. Okay, let's see what we get from this. N is 100, so minus 2 into 100 raised to power minus 1 over 2. That equals 50k into sine of 0 plus c. Now sine 0 is just 0, so this whole thing becomes 0. We get 0 plus c equal to minus 2 over 10. That will be minus 0.2. The value of c turns out to be minus 0.2. You can just put this on your calculator. Put this whole thing on your calculator as it is. You should get minus 0.2 from this. Now, we've got the value for c. Put that back here. And the equation now becomes minus 2 n raised to power minus 1 over 2. That equals 50k into sine of 0.02t minus 0.2. That's a relation that you have between n, k, and t. Okay? They have not asked you for a specific form as such, so you can just leave it as it is. And that's your answer. Make sense? That's the first part. Let's move on. Now it says, given also that n is 625 and t is equal to 50, find the value for k now. Okay, so we've got this point. Use that point to find the value of k. This was the equation. Input this here. Put t equal to 50 and n equal to 625. What do we get from that? Minus 2 into 625 raised to power minus 1 over 2 equals 50k into sine of 0.02 times 50 minus 0.2. Now on the left side, we get minus 2 divided by square root of 625. I think that's 25, right? Yeah, 2 over 25 equals 50k into sine of 50 into 0.02. Is that 1? Right? That's 1 minus 0.2. And now you can find the value of k from this. You can see what that turns out to be. On the left side, we have minus 2 over 25. That's minus 8 over 100 minus 0.08 plus 0.2. That equals 50k into sine of 1. That was sine or sine inverse? That was sine, right? Okay. Now, on the left side, we have 1.2. Please keep a lookout for any careless errors. Is this 0.12? Can somebody confirm this? 0.12 divided by 50. That equals k into sine of 1, and then divide sine 1 on the other side and see what that gives you. What do you get from that? Make sure your calculator is in gradient mode again. 0.12 divided by 50 into sine of 1. K equals 0.002852. Right, your final answer to 3 significant figures, but in the next part now, if you need to use k, use the more accurate number, 0.00285. That's the value of k that we're getting. Is that okay? All right, let's move on. Now it says, obtain an expression for n in terms of t and find the greatest value of n predicted by this model. So now we need to make n the subject. N in terms of t means n needs to be the subject. How do you do that now? You take minus 2 to the other side, divide the whole thing by minus 2. Divide the whole thing by minus 2, and that leaves you with, and in fact, we've got a negative power of n here. What we can actually do is write it like this, first of all, minus 2 over n raised to power 1 over 2. That equals 50k into sine of 0.02t minus 0.2. Right? And now take this to the other side and bring that here. So you get minus 2 divided by 50k into sine of, no, we have got the value of k as well now. We can input that here. Let's do that in this step. We know the value for k now. Let's input that here. The value for k was 0.002852. Okay, so what does that become then? This was the answer that we were getting here. Multiply that by 50. That's 0.1426 times sine of 0.02t minus 0.2. That equals n raised to power 1 over 2. Now we square both sides, and that gives us n equals, when we square both sides, minus 2 whole square, that becomes 4 in the numerator. So n equals 4, 4 divided by 0.1426 into sine of 0.02t minus 0.2 whole squared. Okay, that's n in terms of t. That's one thing that we wanted to find out. And now they're saying find the greatest possible value of n. Greatest possible value of n predicted by this model. Okay. How can we get the greatest possible value of n predicted by this model now? What's the variable here? The variable is only this, right? T is the variable. And that is inside the sine function here. So normally when they have questions like these in differential equations, what we do is we input a very large value of the variable, right? But that's not what they're talking about. They're not saying as t becomes very large. They're not asking about that. In this case, the function is actually a sine function. Now, sine function is a cyclic function that goes like this, right? So even when t becomes very large, it's not going to approach a fixed value. It'll keep changing like this, right? It'll keep changing like this because that's the pattern that it keeps following. Now, if we are looking for the extreme values of sine, when do we have them? This is one extreme value. This is another extreme value. What are those values? 1 and -1. So what we do is when we're looking for an extreme value of a function, just like in paper 1, when we used to find range of trigonometric functions, what did we used to do for that? We used to use the extreme possible values of sine and cos functions in problems like these. Sine function is between -1 and 1, right? Values of sine are between -1, are supposed to be between -1 and +1. So what we can do is we can say, let's input this thing as 1 and then input this thing as -1. And that's going to give you the extreme values of sine. Since we have a square here as well, in square, sometimes 0 is also relevant because of the square. Because when you square something, if it was a graph that looked like this, what happens is the negative part that becomes positive. So the minimum value becomes 0 in that case. Although in this case, the square is on the whole thing and not just on sine. So the extreme values are going to come from 1 and -1. But you can just make it a standard rule for yourself. Whenever you have a square with sine and cos, you use 0 as one possible value as well. So try what happens when sine is equal to 1, what value of n you get from that. See what happens when this is equal to -1, and then just for making sure that the answer is correct, you can try 0 as well and see what values of n you get from that, because these are the extreme possible values of n, extreme possible values of sine 1 and -1. They are going to give you the extreme possible values of n. Let's try that on a calculator. We'll put it like this. We'll say 4 divided by 0.1426 into 1. That's the first case that we're checking. Minus 0.2 whole squared. What do we get from that? 1214. Okay. We're talking about number of insects, right? N represents the number of intersects. Number of insects, not intersects. Number of insects. So we should write that as an integer. We're talking about number of insects, right? So this is one value that we're getting. Now we don't know if this is the maximum value or the minimum value. We don't know that here. Try -1 as well. See what that gives us. Okay, that's giving us 34. So that's most likely going to be the least value. 34 point something. Let's just say 34. And then you can try 0 as well if you want, just to cross-check. That's 100. That's some value in the middle. What's the greatest value that we're getting? 214. That's what your final answer would be. We'll say that's the greatest value. Make sense? We consider 0 when we have a square. In this case, that does not matter because the square is actually on the whole thing. But if we just had, for instance, sine square of 0.02t. If you have something like this, then we have to consider 0 as well. In this case, we did not necessarily have to do that, but just to give you a standard method for questions like these, I would recommend that you just check these three numbers. When sine is 1, -1, and 0, if there's a square involved as well, then you also consider 0. Okay. If there's no square involved, then you just check 1 and -1. Those will be the extreme values that you have in that case. Is that all right? That was question number 8. Let's move on. I think that's pretty much it. I'll just look at the other questions quickly. 9 is this vectors question. No one has asked about that. It's just angle between vectors, and then foot of the perpendicular. That's a standard method. We've done so many of them. Reflection of A and L. Okay, I'll tell you about this part maybe. You found the point of intersection, have you? No, you haven't. But you found the foot of the perpendicular. Okay, all right. So I'll just assume some numbers for you. Okay, because I've not done the first two parts, or maybe if you can tell me the answers. Does anyone have the answers for the first two parts? In fact, not the first part, just the second part, foot of the perpendicular. What's that? Foot of the perpendicular, what's the answer for that? Let's call that point X, foot of the perpendicular. 2, 4, 7, thank you. 2, 4, and 7. So let's say that's the answer from the previous part. And now this is the line L, the point A that they gave. The point A was 1, 5, and 6. We can think of it in terms of coordinates as well, so that will make it easier to work with. Point A is 1, 5, and 6. 1, 5, and 6. That's A. And the foot of the perpendicular from A to the line, this point X, that's 2, 4, and 7. What's the position vector of the reflection of A in the line L? Where will the reflection be on the other side here? And you have some point here on the other side. Let's call that point something. Let's call that point B. That's the reflection. Right, let's call that R. What's the position vector of this? Can we find the coordinates? X is the midpoint of AR. We can think of it like this. We actually learned this in coordinate geometry in P1 as well. You've got this point A. You've got this point X. That's the midpoint. 2, 4, and 7. And you have to find the point R. How many units do you have to go from 1 to 2? 1 unit. You have to do +1. In order to go from X to R as well, the X coordinate will change by 1. So that gives you 2 + 1, that's 3. In order to go from 5 to 4, you have to do -1. You do -1 more, and that gives you 4 - 1, that's 3. From 6 to 7, you have to do +1. You do +1 more, and that gives you 8. So the point R has these coordinates. They wanted position vector of R, not the coordinates. You would say the position vector of R is 3, 3, 8. And that's your final answer. You can use the midpoint formula as well. That will be slightly longer, but you can do that as well. So x1 plus x2 over 2, y1 plus y2 over 2, z1 plus z2 over 2. X is the midpoint of A and R. You assume this to be x, y, and z, and then find the values of x, y, and z. You can do that slightly longer, but that will work as well, yes. Okay, all right, let's move on. Question number 10. Okay, that looks like iteration. Okay, so just the first part of this, the second and third parts you can do. Okay, that's the last part that we're doing for today. And then question number 10, part A, then we end for today. The first part, it says the constant A is such that integration of this x squared times ln(x) with limits from 1 to A is equal to 4, so that A equals this. That's actually not that complicated as well. That's integration by parts. What's the formula for integration by parts? Integration of uv dash, that is given by uv minus integration of u dash, right? That's the formula that we got for integration of parts. All right. Now, how do we decide if we have to take x squared as u or ln x as u? You can use 𝗨𝗏 for that. Whatever is on the left side in 𝗨𝗏, that's u. Whatever is on the right side, that's v dash. So in this case, we've got x squared, that's algebraic. And ln of x, that's logarithmics. L is on the left side in 𝗨𝗏, that's u. And a is on the right side, that should be v dash. So we say, when we do this integration, u should be ln of x and v dash should be x squared. And then we just have to input values in the formula uv minus integration of u dash. Okay, now before we do this, complete this, just a reminder, tomorrow we have the P3 revision workshop, right? We've got P3 revision workshop. We will be starting around 4 to 4:30 p.m. inshallah. 4 to 4:30 p.m. It's going to be a long session. We will end around 10 tomorrow. And then similarly, the second part will be the day after tomorrow. We will revise all the P3 topics, all the concepts that you have in all the topics, along with the different types of questions that you get in each of those topics, right? Now, you guys were part of the past paper sessions. You don't have to register for them separately. I'll be adding you to the group. If anyone else, they can register using the registration link. They can register using that. But those of you who are part of the past paper sessions, you don't have to do that. But do share with your friends so that more people can benefit. Anyone who wants to register, you can share the link with them. I will share that in the Zoom chat here as well. Or maybe I'll just do that in the WhatsApp group later on. I'll just write that down. So if you want to share that with anyone, you can do that using this link. Okay, all right. Now let's have a look at this. uv minus integration of u dash. Let's input values in this. U as it is. That is ln x into v. We have to find the derivative of ln x, that's 1 over x, integration of x squared, that's x cubed over 3. So ln x into x cubed over 3, that's what uv is, minus integration of vu dash, that means x cubed over 3 into u dash, which is 1 over x. That's what we have to integrate now. Outside, we have x cubed over 3 into ln x already. We keep that as it is. This is 1 over 3. We can write that outside. Inside the integral, what are we left with? Just x squared, because one power here is going to get cancelled with this x. What's the integration of x squared now? Integration of x squared is x cubed over 3. And that's the integration part done. Now we just have to input values as an input the limits. What were the limits? And limits were from 1 to a. Integration is done. Let's input those limits now. Input a first of all, that becomes a cubed over 3 into ln of a minus 1 over 9 into a cubed. Subtract from this the case. Okay, so they actually gave us that this integral is supposed to equal 4. Okay, so we can put this equal to 4. So minus the case when we input ln equal to x equal to 1, that gives us 1 over 3 into ln of 1 minus 1 over 3, or you can say 1 over 9 into 1 cubed. That equals 4. Now we just have to simplify this and convert it to the form that they want. Okay, so you see what they want? They want one a on the left side and the other a that is inside log, that is on the other side. So that means we have to make this A the subject, right? That is outside log. The A that is outside log, that has to be made the subject. Now, how do you do that? You can simplify this first of all, and that will give you a cube over 3 times ln of A minus a cube over 9 minus ln 1 is 0, right? So that just gets eliminated, plus 1 over 9 minus 4 equals 0. Now, we want to make this A the subject. I can just take that to the other side because this is negative. It'll become positive when it goes to the other side. Let's simplify everything else. A cube over 3 into ln of A. What about this? 1 over 9 minus 4. What does this give us? Minus 36 plus 1, that's minus 35. Minus 35 over 9, that equals a cube over 9. Multiply the whole equation by 9. That will give us 3a cube. 3a cube into ln of A minus 35, that equals a cube. And that tells me that something is wrong somewhere. Something is wrong somewhere, right? Because we are not getting that. Okay, so there's supposed to be a fraction somewhere. Okay, let me check the working quickly. U is ln x, v dash is x squared. Okay, we found the integration to be x cube over 3. Can somebody spot any error somewhere?
सर a cube over 3 fraction को अगर
Okay. I missed that. I'm sorry. I missed that. There's another a cube here as well. I did not see that. Okay, so there's another a cube there. There's another a cube there. I did not see that. So we have to get rid of that as well. Okay, I'm going to go back a little then, because we want to take this a cube outside as well. I did not see that. So what I'll do instead is I will take the constant to the other side, take the constants to the other side, this constant to the other side. And on the other side, that will become 4 minus 1 over 9. That's 35 over 9. On the left side, I can take a cube common. That leaves me with 1 over 3 ln of A minus 1 over 9. Okay, that's what we get when we take this common here. We can multiply the whole equation by 9 so that things become simpler. If we multiply the whole thing by 9, that will give me 3 ln A here minus 1 equals 35. And now I can divide this on the other side, and that makes sense now. A cube equals 35 divided by 3 ln of A minus 1. Take cube root on both sides, and that will give you 35 over 3 ln A minus 1 whole raised to the power 1 over 3. And that's what you wanted at the end. That's our final result. Okay, makes sense? Not that difficult. You just start to use integration by parts and then convert it to that form. And that completes this third paper as well. We did difficult questions from all 3 variants of June 2022 today. So that basically covers the last 4 years, about around 4 years. Yeah, 4 years live almost. 2025 March, going backwards to June 2022. We've done these papers live, some difficult questions only, some complete papers. And for the others, you've got the recordings available as well. So now that this was the last session that we had in past papers, tomorrow and the day after tomorrow, we've got the revision workshop. And on Sunday, it'll be a live Q&A session in which you can bring any questions that you might have from any papers. But that's it for today then. Okay, so anyone who wants to leave, you're free to leave. There's a question here that Safid has. We will be talking about that next. Let's discuss that next. Okay, let me share that. Okay, so I'll just do this small question that one of the students is asking about, and then we end for today. Okay, let's have a look at this quickly. Let's have a quick look at this. It says the diagram shows a trapezium ABCD in which AD is equal to BC, which is R, and AB is equal to 2R. The acute angles BAD and ABC are both equal to x radians. All of that is shown in the diagram. You've got the recording available for this paper as well, by the way. May, June 21. I've done that there. And in the playlist, you'll find that. They meet at M, okay, which is the midpoint of AB. Given that the sum of the areas, now this is what you will use to make the equation. Sum of the areas of the shaded sectors is 90% of the area of the trapezium. Show this thing. Now, can we find the area? How can we find the area of the trapezium? How do you find the area of the trapezium? Half into sum of parallel sides into height, right? Now, what about the parallel sides and what about the height? Do we know that? We don't. We know one side, this is 2R. What about the height? What we can do is we can say, let's make a triangle like this. Let's make a triangle that looks like this. So make this triangle. It's a right angle triangle. This is R, this is X. Can we find this vertical length? Let's call this something. Let me call this point Y. Can we find CY using this triangle? CY is perpendicular, R is hypotenuse. So we could say CY over the hypotenuse, that equals sine of X. So CY, that is equal to R sine X. So we have the height, right? We've got the height of the trapezium. What about this side, BC? Is there a way to find that? We could find the base BY. Can you find the base BY? And then we could actually make another perpendicular here like this. Let's call this X. BY and AX, they are both going to be the same, right? AX and BY, they will both be the same. We can find BY, for instance, using cos. We can say BY over the hypotenuse, that is equal to cos of X, right? BY over R is equal to this, then BY is equal to R cos X. Now, if that is R cos X, we know this length is R cos X now. If that's R cos X, then this length is also R cos X. Can we see anything about XY then? What's XY going to be? XY is going to be the total length, which is 2R, minus R cos X and R cos X. That's the total, that's the length XY, which is 2R minus 2R cos X. XY is the same thing as CD, right? They're both the same. So now we've got that other side as well, and that's it. Now we can make that equation. Sum of the area of the shaded sectors. Sum of the area of the shaded sector. So what's the area of one sector? Half R squared theta, half into R squared into X, times 2, because there are two sectors. So 2 times that. That is equal to 90%. That means 90 over 100, 0.9 times the area of the trapezium, half into sum of parallel sides. One side is 2R, the lower side is 2R, plus XY or DC, this side, that's this, 2R minus 2R cos X, into the height, which is CY, we found that to be R sine X. simplify this and you would get the result, right? On the left side, we have r squared x. 2 and 2 get cancelled. On the right side, what do they want at the end? 0.9 common outside. Okay, 0.9, we can leave that as it is. We can take 2 common from all of these. Or let's actually first simplify that. 1 over 2 into 4r minus 2r cos x into r sin x. You can divide by 2 here. So that just leaves you with 0.9 into 2r minus r cos x into sin x into r sin x. You can take r common from here, another r common from here. So you get 0.9 r squared into 2 minus cos x into sin x. On the left side, you've got r squared x and r squared x, they get cancelled. X equals 0.9 into 2 minus cos x into sin of x. That is what they wanted us to prove. Make sense? Any issues with this? You can take r common from these two terms. That gives you r once. Another r common from here. That becomes r squared. Right? Okay, good. I hope that was helpful. People on YouTube, I have the revision workshop starting tomorrow for paper 3. It's going to be a complete revision of the whole syllabus with all the concepts revised, including the different types of questions. It will be around 10 to 12 hours in total over 2 days. You can come with your questions as well, and we will discuss them, and we'll be part of a community in which you can ask each other questions from before the exam day in the groups that we have. I'll see you again in that workshop, inshallah. Next, we are not going to be able to have live sessions tomorrow or on Saturday, but we'll have the next YouTube live on Sunday now, the night before the exam. The next YouTube live is going to be on Sunday, the night before the exam, in which we will have a Q&A session. You can come with any questions that you might have, any last minute questions. Tomorrow and on Saturday, I'm doing this revision workshop, so it's not going to be a YouTube live tomorrow or on Friday. Okay, so or on Saturday. We meet next on Sunday before the exam. Okay, that's it for today. I'll see you again in the next session whenever we meet. Allah Hafiz. For those of you who are interested in registration and in registering for the workshop, you can find the link for that in the description below and also in the pinned chat on the right side. Okay, all right. Allah Hafiz.